All right, so this is going to be the second part of the vocabulary, and I'm going to go back and redo sampling. My smart board started messing up, so I'm going to go back and redo this one just to make sure that you had it, okay? So the 5 ways that we've already covered about collecting data, we know that there's quantitative, which has to do with numbers, and then there's qualitative, which is just like a characteristic type that you can put them into. So that's the 2 types of data. Then there's the 6 ways of collecting data. The first one was experiment, which you actually apply a treatment. Then we had observational, where you just sit back and watch. Then we had survey, where you do a question. Then we had a simulation, which was like a computer animated thing. Then we had census, which you have to ask the whole population. And now we have sampling. So our next one is sampling. Okay? And that is a count or measure. It's a count or measure of parts of your population. So whereas census is the whole population, the entire population, a sampling is part. So I'm just taking a sample of it. So your population is going to be the same as your sample population whenever we get to that part. No, those are the same. The only difference is the sample is how many that you, or the part that you took out and used. So characteristic is that it's used to predict. It's used to predict population. Okay? Another characteristic is that it's more practical than the census. More practical than a census. And if you remember, I was telling you that with a census you have to go back and you have to ask everyone in the entire population. But if you're using a sample, you only have to ask the part that you took out. So you're really just getting a little basic. You're getting a little bit more smaller group, but you can still predict your outcome based on that. So an example of that would be to determine the population in a city, such as Livonia, Royston, anything like that, and this is just the example that I'm using here, to determine, so you're going to use that population to determine the population in your county, such as Franklin. So in the county, so since we did Livonia, it would go for Franklin County. So how many ever square miles are in Livonia? Well, this is the population that we come up with for Livonia. How many square miles? So if we were to take and see how many square miles is in Livonia versus how many square miles are in Franklin County, we could predict, it's not going to be exact, but we can predict what our population in Franklin County is going to be. All right. So on this next little chart on page 6, the following chart shows examples of different methods of collecting data used in statistical studies. So we're going to fill it out and figure out which type of the 6, which of the 6 would go with these. Now, the first one, the effect of an asteroid colliding with Earth. Someone will say observational, which is fine. The only problem is that's never happened. And so we're going to go with a simulation. We can use a simulation to figure out what would happen if an asteroid ever hit the Earth, okay? What what kind of, it would be computer animated. Of course, it's not going to be exact. It's not real. We can't predict everything that's going to happen if it was to happen, but we could kind of know, right? So the effect of aspirin on preventing heart attacks. Well, we could do experimental with that one. So experimental. We could also do observational. You could sit back and watch. So observational. You could sit back and watch how somebody reacts to that. If aspirin really prevents heart attacks. Of course, the observational, you can't change anything, especially with the experimental, though. You could section it out and say, okay, these people have had a heart attack, these people have not. You know, I'm going to give them aspirin and see if that helps anything. Next, see if you can figure out these next three, and then unpause the video and continue on and see if you got the same thing I did. I will go ahead and tell you there's not a correct answer, exact one answer. You can narrow some of those 6 choices out, but there's not going to be an exact, definite one answer for these. So if you want to pause it and try these 3, go ahead, and then see if you got what we got. So the weights of all linemen in the NFL. You could do a survey. You could ask them what their weight is. You could do an observational, just because you could watch them get weighed. You could do a census if you want to go and watch all football players get weighed. But you could also do a sampling. Say, okay, I'm going to pick 3 teams. I'm going to weigh them, and they're going to be weighed. I'm going to look at their information, and I'm going to see how many teams I have and figure that out. All right, Americans' approval rating of the U.S. president. Again, I would say survey. You could ask them. Observational, because you can watch the reaction to a president. A lot of times that helps people. All right, to determine if a campus dining hall should open a pizza bar. I would say survey on that one for sure, because it's going to be hard to watch an observational because you don't have a pizza bar. But a census, still you could go around and ask everybody. So, all right. So an important concept in collecting data is randomness. So randomness. To get a true sample of data, the collecting process must be random. So in other words, everybody that you're wanting to collect information about has to have a chance of being picked. You may not use the whole population, you may use a sample size, but everyone in that sample or everyone that's in that population has to have a chance of being picked. For instance, I'm going to ask Franklin County High School if we should have school uniforms. Well, I need to set up a way so that I know all students will have the opportunity to be picked, okay? So we're going to look at this example. From a class containing 12 girls and 10 boys, 3 students are to be selected to serve on a school advisory panel. Here are 4 different methods of making the selection. Number 1, select the first 3 names on the class roll. Number 2, select the first 3 students who volunteer. Number 3, place the names of 22 students in a hat, mix them thoroughly, and select 3 names from the mix. Or number 4, select the first 3 students who show up for class tomorrow. Which is the best sampling method among these 4 if you want your school panel to present a fair and representative view of the opinions of your class? Okay, so we're going to pick the best one of picking our 3 students. So if you want to pause this a second and read through them again, see which one would be the one that you would actually have a chance of all students being picked. And then if you think you've got it figured out, and then unpause the video and see if you've got it right. All right, so for all students to have a chance to be picked, it's going to have to be the third one. Put them all in a hat, shake it up and randomly draw those out, okay? Now, we've got to figure out what's wrong with these other three, though. So the first one, if we pick the first three people on the roll, it doesn't give everybody a chance because people at the bottom of the list. So it doesn't give everyone the opportunity. And again, it's because those at the bottom of the list, they can't help what their last name is. All right, so the second one, select the first three students who volunteer. All right, the problem with this is you may have somebody that's out. First off, you may have somebody that wants to volunteer, but they're scared, so they don't raise their hand. You may also have a student that is quicker. So those that are slower at reaction time, then they're going to be left out. All right, the fourth one. Select the first three students who show up for school tomorrow. Well, some may be out. So they may be out because of sickness, whatever. They may be late, and it could be because they overslept. A bus, they could be out or late because of the bus. You never know. They could be farther from the class. So farther from class. For instance, if I pick the first three that walk into my class tomorrow for this, and then if two students have science, or if half my class have science or social studies, and the other half are in the CT building, the ones that have science and social studies are probably going to get here first. So you have to make sure everyone has a chance, okay? All right, next page. Not using a random sample often introduces bias into your sample. So it introduces biasness, okay? A biased sample is one in which the method used to create a sample results are not representative of the population. For instance, I'm asking I want to know if SCHS should have uniforms. Well, I asked the girls. If I only ask the girls, then that does not properly represent my population because my population is Franklin County High School students. The ones that I'm asking are only the girls. I'm leaving out the boys. So I'm showing bias towards one group. All right, so an example of a bias sample would be a sample consisting of only 18 to 22-year-old college students if the statistical study was to research the 18 to 22-year-old population of the country. So a lot of people want to look at this, and when we're going to talk about being biased, they want to say, oh, because 18 to 22-year-olds. Well, if you look here, we're doing 18 to 22-year-olds. So the age is fine. The problem comes in, we're doing college students for the population of the country. Not everybody goes to college. Some people may not can afford to go to college. Some people may want to wait till later to go to college. So you're kind of narrowing out those that don't go to college. All right? All right, so I'm going to do the first one, and then I want you to pause your video, see if you can pick out the next 4 or 5 what's biased about them. There is one that is not biased. There's no bias in it at all. See if you can figure that out. Unpause the video and see if you got them right. If not, correct them, and I'll explain where I got them from, okay? So in each scenario, we're going to see if it's biased, and we're going to tell why. So number 1, a medical company uses sick patients to test their competitors' drugs for side effects. Well, they're only using or only testing sick patients. Okay? So now see if you pause the video, see if you can pick out the next 5, and then see if you got them right. All right, number 2, a medical company uses healthy patients to test their competitors' drugs for side effects. So number 2, they're only using healthy patients. All right, number 3. A newspaper polls 9th grade students to measure if students are going into the armed forces after high school. On this one, they're only asking 9th grade. And we all know when we're in 9th grade, our minds change by the time we're seniors. All right, number 4. The Department of Education conducts an online poll that asks, do you have internet service at home? This one's kind of funny to me, but it's an online poll asking if you have internet service. Now, this wouldn't be so bad if they had parents come in at school, but then again, it becomes convenient, which we will get to. Okay? Number 5, a survey is mailed to voters in Augusta asking, will you vote for the 1-cent sales tax in Augusta? All right, so we're asking people in Augusta about something going to happen in Augusta, so that is fine. It's also mailed to voters that are going to vote, so that is fine. So in this one, there is no bias, so there is none. Okay? All right, number 6. A survey is mailed to voters in Augusta who make more than $90,000 a year asking, will you vote for the 1-cent sales tax increase in Augusta? And it's more than $90,000. Okay? So that is what is biased in each of these. All right? All right, in your next little chart, this shows the different types of sampling techniques. And again, simple random samples should be your easiest, okay? Because it is a sample, you're taking part of your population. And random, remember, everyone has to have a chance of being selected. So everyone has a chance to be selected. Okay? And we have stratified sample. That just means that we're going to split everyone that is in our population into groups that have similar characteristics. So they'll be separated into groups by characteristics. So for instance, we're going to ask Franklin County High School, do we do uniforms? Okay? Well, as long as I do, let's say, I'm going to ask math teachers to give this survey to their students. Well, everybody has a chance of being picked because, or has a chance of being, of answering this question because everyone has math at some point in time. Okay? So that's where it would be random. Okay? Now, if I wanted to do stratified, I would say I would have it put on there, circle male or female. All right? So then I'm separating it into groups. Boys say this, girls say this. All right? Cluster. I'm going to have subgroups of my groups. So subgroups. Subgroups. And what that means is I'm going to ask, should FCHS have uniforms? All right? Should FCHS have uniforms? That's stratified as long as I do it to where everybody has a chance of being picked. Then if I say male and female, then that puts me into one characteristic or into where I have one set of characteristics. Well, then I'm going to split it on down even more than that, and I'm going to do it with ethnic groups, based on your ethnic group. Or I could say based on your grade level. Okay? So those are some more ways. So I'm just pretty much breaking it down even more. The more I get it broken down, the more it's going to be like a cluster sample. Okay? All right, a systematic sample is that you are assigned a number. And I'm sure that all of you have been assigned a number at some point in time, especially if you go to the DMV. I'm going to give you a number. You're going to have to wait. The only difference is I may say in my class, okay, I'm going to number you 1 through 30. Okay? Everybody has their number. All right, if you have a number that has a multiple of 3, then you're going to take my survey. Okay? So that means that I am dealing with something with a number. Okay, so systematic just means number. Then we have a convenience sample. A convenience sample means that it's for people that are available. So you are available at that time. So for instance, I'm going to say, I'm going to do a survey. You can come between 12 and 1. Well, that would be for those that are available. The problem with this is I'm introducing bias. This one is more likely to introduce bias because I'm pushing out the working people, the people that have to work between 12 and 1. Okay? So just be careful if you do a convenience sample because that you are going to end up with a bias information. All right. So going over to page 9. So the following word problems determine if the data collection is a sample, observational, or an experiment. That's what we're going to find. We're going to identify the population, and the sample, and then our characteristic of interest. So a population is the entire population of the people or items you are collecting more information about. Okay? Your sample is the chosen group from your population. So if I go back to my FCHS uniform thing, my population would be FCHS students. If I said I'm going to ask all students in math, it would be students taking math. That would be my sample. Okay? So my population is the FCHS students, but my sample is the students that are taking math because that's the ones that I'm going to ask. So my characteristic of interest is the topic for my study. So in this case, it would be school uniforms. Okay? All right. So that's a few things that we're going to look for in the next few word problems. So a pharmaceutical company is interested in comparing 3 brands of pain relievers. The company wants to know if one brand is much better than the other brand in the terms of mobility improvement. 3 different groups of 30 participants are in the study. Each group gets one of the 3 brands of the pain relievers. The improvement of mobility of these 90 people is recorded after 5 weeks of taking the medicine. So the first thing I'm going to look at is the type. Well, since I'm giving them a treatment, it is an experimental. Okay? My characteristic of interest, which I label as COI, is I want to know if one medicine is better than the other. One medicine is better than the other. All right. Now, my population are the people that I'm wanting to see who it helps. So people with mobility problems. With mobility. All right, and then my sample is the ones that I take out of that. So the people that I take out of mobility problems, so usually a number or a little set. I'm going to have 3 different groups of 30 people, so 90 people that have the mobility problem. So 90 people, okay? All right, my next one. My type, my COI, which is my characteristic of interest, my population, and my sample. All right, medical records of a group of long-term residents of a town are compared to medical records of a group of long-term residents of another town. Researchers are curious to see if one town appears to be healthier in general. So my type, I am just looking at their medical records. They compare the medical records. Okay? So that is observational. All right, my characteristic of interest, if you look, they're curious to see if one town appears to be healthier. So, is one town healthier than the other? One town is healthier. All right, that's what I'm wanting to know about. My population is the people in the town, because I want to know if the town people are healthier. So town people. But in those town people, the people that I am looking at are long-term residents. All right. So then the next one, we have a group of 600 registered voters in a given county. They're asked how they intend to vote in an upcoming election. A summary of their responses is posted on a news website, and it is implied that this group is representative of all registered voters in that county. The responses are used to predict the outcome of the election. So see if you can figure this out real quick so the announcement's finished. All right. So my type, I'm asking them how they intend to vote, so that's going to be a survey.
Awesome. If you're a bank member and you haven't sold all of your tickets, please give those to Ms. Miller.
Now, my characteristic of interest. What am I wanting to know? If I look right here, it tells me. I want to know the outcome of the election. All right. Now, my population, who are they wanting to know about? They're wanting to know how people intend to vote. So, my population is registered voters. Then my sample size is what I took out of that population. And if you look, 600 of them. So 600 registered voters. All right. Pause the video and see if you can do the last one real quick while I'm getting it ready to go. All right, so we have our last one. It says in a study to see if administering a medication orally or by injection makes a difference in how quickly people with back pain feel relief. That's what I'm interested in. So, which type, so my characteristic of interest is going to be injected or orally taken medicine, which is better. Or works faster, however you want to write that. Okay? So if I continue reading, a group of 400 adults suffering from back pain. So a group, that right there lets me know that's my sample. It says 400 adults. Well, my population, I want to know who is being affected. Well, I want to know the adults suffering from back pain. So that is my population. So adults suffering from back pain. All right. They're divided into two groups. One group of 200 is given medicine and pill, while the other 200 are given the injection with a shot, or given the medicine with a shot. Results for each group are compared to see if there's a difference, pain reliever, and the difference in pain reliever between the two methods. So my type, I'm giving a treatment, so it's going to be experimental. Okay, so that's just being able to know how to, what you're asking, what you're wanting to know, that's important. All right, so we're going to do this again. I want you to pause the video, and I want you to go through the next few, and I want you to see if you can tell if it's experimental, observational, or maybe even a survey, okay? You don't have to give me the population. You don't have to give me a sample size, nothing like that. Just tell me if it's experimental, observational, or survey, okay? Once you finish, unpause the video and see if you've got what I've got. So, page 10, at the bottom. Determine whether or not exercise prevents colds by randomly selecting a sample of subjects and recording the amount of exercise they do and the amount of colds that they get within a year. So I'm not changing anything, I'm just looking at them, so it's going to be observational. I'm not making people go exercise. I'm not telling them not to exercise, so I haven't changed anything. So that one's observational. All right? Assign a group of volunteers to a specific exercise regime and allow another group to not exercise. After a set amount of time, record amount of exercise and the number of colds for each year. Well, I'm going to assign in a group, and I'm allowing another group not to exercise. So that is going to be experimental. Okay? All right. A study is conducted to investigate the relationship between owning pets and happiness. 100 subjects are randomly selected, and data on whether or not a pet is owned and a happiness score. All right? So all I'm doing is I'm randomly picking 100 people, and I'm watching if they have a pet and what their happiness score would be. So that's going to be observational. I'm not changing anything. I'm not giving anybody a pet. I'm just seeing how it affects them to have a pet or not. All right, 210 college students are randomly assigned to play either a violent or nonviolent video game. Short time later, students were asked to answer aggression-based questions to find if the type of video game played affected a person's attitude and well-being. Well, I have 210 college students are randomly assigned. This word right here lets me know, usually, that I am telling them to do something. I'm telling them to play a violent or non-violent game. So I'm picking what they are doing. So this one is going to be experimental. All right, a group of parents want to see if unlimited access to TV affects the child's attention. The parents break the children into two groups. One group is allowed to watch unlimited TV. The other group is limited. Well, here you go. One group is allowed to watch it. So you are changing something in them. You're allowing them to. And the other one, they have limited and unlimited. So you're basing the time on it. So this is going to be experimental. All right. Group of students want to observe the effects of drinking coffee, or that drinking coffee has on sleep. They record the sleep times of a group of adults who drink coffee throughout the day. So they're not changing anything. They're not making anybody drink anything. So this one is observational. They're just recording their data that they're collecting by watching. All right. That is the end of this part of this unit. You can go ahead and watch the next part if you would like. But the vocabulary, just review it. You need to know the vocabulary very well, just to keep it in mind, okay? The main three that we